scrolling down, we had in EER diagrams this notion of multi-valued attributes, such as one student or having multiple majors. We could do something like that, or say student has major, major program, and major. Okay, there it's being shown major as an entity. Well, to do that, we would probably do something like 0 or more students would have 0 to 3 majors. Okay. There's an example we had seen before for weak entities. In UML diagrams, we would show the weak entity as transaction ID, kind of hanging off the class. Use a diamond with a line to show a particular transaction. So this is known in UML as a qualified association, as a way of doing weak entities. Like EER, UML has this notion of superclass and subclass. So to show a disjoint in EER, we have an opened UML that is not filled in. To show overlap, we would actually fill that in, the little triangle there. So for an example, we might have a person and disjoint, which means they're a full-time employee, full-time student, but not both. But if they're a full-time student, they might be a graduate, undergrad, or both at the same time. So if it's open, it's disjoint. Filled in, it means overlap. Now another idea I want to point out is in UML there's what's called composition versus aggregation. And I've checked quite a few textbooks, and from the textbooks I check, they all seem rather fuzzy on this, and this is about the best definition I can come up with. For a composition, basically it is a kind of it uses a filled-in diamond, and it's a strong form, and it refers to physically included. So the university might be composed of a math department or other departments per se, and they are actually part of the university. Aggregation is shown with an open diamond, and it's not as strong, like physically a part of, as a composition as I had shown before. So a car might be made of 2 or 4 doors or have so many wheels, but you can take the wheels off of one car, put it on another car. And typically, you might think of the keys in your pocket. I've got a list of things in my pocket, but they're not part of the pants that I have on per se. To represent constraints in UML, we might use curly braces such as balance must be greater than 0. Also, we use curly braces to show comments. And so here's an example of aggregation versus composition. Now the diamond, filled-in diamond, shows that a rectangle is made of 4 lines, but then we might have this notion is the rectangle, is it colored, is it filled in per se, and so it's not as physically tied to the rectangle as the lines. Now you could argue that it is, and that's one reasons why I'm not too fond of the distinction between the two, because it gets into a lot of subjective interpretation. Okay, moving along, we can also have dependencies in UML class diagrams. For example, we might have car, and we might have methods like start engine, stop engine, or fuel level, some integer value, and then we could have that being a dependency on whatever type of engine that might exist within the car. So next, I just want to mention that rationale is probably, if you do any UML designing professionally, you'd want to use the Rational Rows package, and I've got a link to that there. There's also a quick reference, Rational Quick Reference. I provide the link there. And to conclude, let me talk about this Eer UML checklist. Here's things you want to consider when coming up with an Eer UML diagram. First of all, you have to think about the nouns in the requirements document. Major nouns will become classes. Minor ones or adjectives will be, or minor nouns will be subclasses. You need to think about whether they overlap or they're disjoint. And typically adjectives become attributes to the entities. You also need to, as you go through requirements document, identify the attributes. And by identifying attributes, they'll become either relations or associations. Sometimes trivial verbs can be thrown out. Okay. Now, one of the things you want to think of, how do the nouns interact with each other? And you need to consider, well, what's the cardinality of the relation? Is it one-to-one, one-to-many, many-to-one, or many-to-many? Are there any entities that are weak? And what are the keys for each of the entities? And is the participation total or partial? Now from here you can go to building some tables which you'll eventually set up in some relational database. Okay, well that concludes the video on UML. We'll stop here. One of the things I do highly recommend is I've got the in-class example which is given on page 38. Please take a look at that, and the more you can work on it before class, I think the more you'll get out of the class when we discuss it. Now, I'm not going to be posting a solution to that, and it's not a requirement. This is only for your own benefit. Thanks a lot. Bye-bye.